So I'm Seth Welday, and I'm with Seed Studio. And I'm going to go ahead and tell you a little bit about our company, tell you about a new kit we have for the UP board, the UP squared board specifically, which features an Intel processor on board. And I'm going to show you a little demo, and then we'll do Q&A. But also, I'm going to talk a little bit about IoT in terms of connected devices, like sensors that may not themselves be directly connected to the internet. Things like the UP board can actually help you with that. So I'm going to go ahead and, in 1 second, toss you over to the quick slideshow. So, like I said, I am Seth Welday, and this is Seed. We're based in Shenzhen, China. So we do three things. We help prototype, produce, and promote. And as I said, we're in Shenzhen, China. This is a very special place. We are basically the Silicon Valley of hardware. Most of your hardware is actually made here. And what makes that very exciting is you can have rapid prototypes designed, which is always a nice thing, and get to the next version of your product quicker and quicker. So we have offices located in Tokyo, Chengdu, China, and also we have one employee out in San Francisco to meet with our partners and our customers. We ship global, so we've shipped to, I think, 210 countries now. And I guess that's kind of enough about the general company information. So the three things we do is prototype, produce, and promote. For prototype, we offer a bunch of kits, dev boards, sensors. An example would be what I'm going to show you later, which is our developer kit for the UP squared board. With this UP squared board, it is a Raspberry Pi format where you can punch in you can put on a shield that has a bunch of what we call Grove connectors. It's a connector that we use to easily attach a bunch of different sensors. Once you have that shield on the Raspberry Pi, you can punch in a bunch of different sensors. There's no soldering involved. And these sensors are open source hardware and software. So you can always see the code and easily port it over to different things. And if you have any questions, feel free to ask, because I do have a coworker looking at those. But this allows you to rapidly prototype, and not just with the UP squared board, but also things like the Arduino and other development platforms as well. So this is how we help people actually prototype, is by giving them a bunch of tools and open source software and hardware. As it says here, we have developed over 1,400 products. And I would say about almost 500 of those could be called development boards, but not all of them had processors themselves on there. About 180 sensors is how many we've made in total, and actuators like servos and motors. But I think we currently only make about 130 different ones now. When we go to produce, we do two types of, we help in two different ways for production. We do have our own factory where we produce our components. And we have one service that we like to call our Seed Fusion service. This is where you can submit PCBs and PCBAs. For those of you that don't know, PCBs are obviously those boards like your motherboard. PCBAs are when those are actually assembled and have the parts placed on them. So our Seed Fusion service does this. And we make about 8,000 boards a month through our Seed Fusion service. And then the other side of what we do is actually OEM, which is original end manufacturing. That's where people come to us with their products and their ideas, and they already have the design and engineering mostly done. They use us just to do manufacturing. A lot of times we do what's called DFM, design for manufacture, where we take their stuff, edit it a little bit to make it much more likely to succeed in manufacturing and lower the cost. And then we also have our ODM service, which is where there are designs that we customize to help fit a specific solution. We've actually helped over 50 Kickstarter, Indiegogo, crowdfunded type projects go through and be successfully delivered. So we've had a lot of experience in that. Also, we promote. So we have over 506 online retailers. So if someone that we produce or manufacture their product, whatever it may be, a kit, or else it's just a simple board, we can sell it through our sales channel. That includes our website, DigiKey, Mouser, Radio Shack, and we have some very localized stores as well. So say you're in Romania and you want to target Romania specifically, I think we now have a Romania-specific, geared website. So we can help that way as well. In fact, some people only use us to prototype, some people only use us to produce, some people only use us to promote. We offer all three of these. The general idea is that we grow the difference. Whatever area you're weak in, we can help you with. All right. So these are some of our partners. Obviously, Intel, Microsoft, Google, AWS. They provide a lot of our base technologies. We then also use a bunch of open source stuff. For instance, Arduino, they have great open source boards and code, BeagleBone, Raspberry Pi, Dexter Industries. We're active in the maker community, and we help different accelerator programs. And then we also have some good industry contacts that we've found through DigiKey Mouser. They can help us connect and talk to people easily. So let's go and talk about our products. This is some popular development platforms. You can see the Intel Edison on there, which is now discontinued. But we build customized shields for any real popular development platform. For instance, the Up Squared board actually uses the Grove Pi, which is the same format as fits on the Raspberry Pi, that you can connect all these different modular sensors and actuators to. What's very exciting about this is that when people have these tools, they're able to make a lot of online guides. Sorry about that. They're able to make a lot of online guides, and that can really help developers and makers both quickly find how to use their new products, their new boards, and get through and succeed in their products. There's been times I know our engineers have been looking for a solution to a new chipset, and they are able to just find it due to the makers and developers who have written guides on their journeys through them. So it's very helpful for the development process. So as I said, we don't lock you into any specific platform. We want to play with everyone because they all have their different areas. For instance, the Arduino is great for a lot of low power and low processing applications, whereas the Up Squared board is actually phenomenal for edge computing, a gateway device, and just acting as a server in your local home or building, which is incredibly important because if we all remember when AWS went out for a while, all these smart home devices stopped to work. So if you can actually run part of that locally on the edge by having a little mini home server to handle all that, the building, the house, the factory, whatever it is, can continue to run. And that's very important. So again, with this, you can actually choose your choice of cloud, Bluemix, AWS, etc. So over here, we have our other products that are pretty new. There are WIO series. We have our WIO tracker, which has GPS, Bluetooth 3, and 2G. And we have our WIO tracker LTE Cat 1. So I'll explain these real quick. These are made for low power applications, just tracking. The processors are only 48 megahertz. And in general, these are kind of just development boards for people to play on. But if you want to customize these to fit your application, maybe you want to add on different connectors, add on sensors on board, we are able to do that and customize that. And that's part of Seed's services. So the LTE Cat 1 is our newest one. As some of you may know, 2G is being shut down in many countries, usually mostly Western companies. And we are working, and so what's going to replace that is new LTE technologies like Cat 1. The Cat 1 modules the modems, I should say, are going to be cheaper to buy because they're less complex circuitry, but they also use lower power, which is excellent. The downside is that they get much lower bandwidth. So with this Cat 1 technology, you're looking at 10 megabytes upload, or 10 megabit, I think, 10 megabit upload. I think it's 5 megabit download, somewhere around there. So it's good for some applications, but not all. And LTE is also rolling out Cat M1, which is up to 1 megabit per second. And down the road, narrowband IoT, and that's going to be around dial-up speed. So some applications for this type of stuff is litter detective. So in this case, we teamed up with the World Wildlife Foundation, Maker Bay. They made a bunch of little sensors that they could send out, track the currents of the ocean, and see where litter is ending up. So you could actually figure out where to clean this up. It's very good for research efforts. I'm sure quite a few of you may have heard of similar projects to this. Another one of our products is the ReSpeaker. This is actually for voice interface. The idea being, instead of having to control things with your hands, similar to Alexa and Google, you use your voice. But this is a hardware platform that you can run whatever you want on it, so you can have more flexibility. Good uses for this are to control all of your smart home devices, as you've seen, but also maybe putting into hotel rooms or in shopping malls. You can walk up to a kiosk, speak to the kiosk, and get an answer. Currently, when I go to some shopping malls in the US, they have touch screens. I have to navigate through menus that aren't always clear. If I could just ask it a question, for instance, hey, where's Macy's? It'd be really cool if it could just display that right back to me quickly instead of me navigating through some menu. So this is more about our manufacturing services. I'm going to go through this a little bit more quickly now. We have ODM and OEM both. ODM, some of our projects that we've done have been for education, voice interaction, smart agriculture, gateways. And for some of you that don't know some of those abbreviations, the process is simple. You go through requirements for work. Followed by that, we have the product requirement document made. Then we go to design, debug, and release. We can also help through certification, as we've gone through that several times ourselves. In addition, we also have our OEM services, in which case you pretty much already have your design figured out. You might want us to help reduce the cost and help customize it so you can manufacture them cheaper. We build test jigs, and then we go to mass production. I should emphasize at this point that seed mass production is about 10,000 units. So we work with people that need smaller batches, either for testing or maybe they only need like 10,000 in total made for their company. That's what we focus on. We don't really go up to like 100,000, though we can design those products. And we can also find manufacturers for those as well. This is about our Fusion service that I mentioned earlier. It's pretty quick. You can do one up to 1,000. And then it has a 25-day average lead time. Also, one great thing is, since we make a lot of our own products, we have what's called the OPL, the Open Parts Library. So if your device can use one of the same components we use, you get a huge discount because we already order that in a large amount. With Fusion, something I didn't mention exactly was that we have mechanical services as well. So we offer 3D printing, laser cutting, and CNC milling with Fusion as well. This is really great for startups or personal projects. And actually, a lot of companies use this too. So back to our ODM, OEM side. We have what my boss likes to call the soul, gut, skeleton, and skin. The soul is more of the software and how you would test it. The guts are the actual electronics, skeletons the mechanical, and the skin is everything from certification, the packaging, the user guide. We help go through all of these. So I know there's a lot of information here, and if anyone wants to talk about this later, we can. As I said, we do small quantity manufacturing, and our facility does what's called agile manufacturing, meaning that we can switch over our machines very quickly to produce new devices. And larger factories, where they produce hundreds of thousands, it can take them a few days to switch over. But in a factory like ours, we can easily do about 3 to 5 products a day. So as an example of a client we worked with, we recently did something with Nivea. You might know them as the cosmetics company, lotion for men. In China, we have something called the Wrap of China. And it's a very big show, and everyone's getting really excited by it. So Nivea wanted to sell something to the Chinese market that would appeal to all the fans of this show. And so they gave us a project. We signed off on it on August 14th. And it took us 41 days to produce all 20,000 that they wanted. So we did all the prototyping, debugging, and sending the device back and forth to get their approval, all within 41, and manufacture, all within 41 days. So we do all services, and this is a very fast turnaround time for 20K of a product, especially when it had to be designed from the ground up. The next one I want to go over is the ArduBoy. This is open source programming so that you could actually write your own games for it. So for this one, we did a lot of, this was an OEM project, but we did do some manufacturing design for it. So as you can see, we helped design some of the layout. We did a lot of, we revised a lot of the parts they used. We revised their layout a little bit to reduce the cost. And we helped them with certification. We helped the supply chain and manufacturing. But the base schematic and a lot of the parts that they had first chosen were all done by them. This is a case of OEM. And it's been a pretty successful product. Many people have liked it. And he even made a version for Tetris. So if you go to these links down here, you can actually see some of the Kickstarter projects we've helped bring to life. And you can see them above as well. We actually have made the Crazy Fly. And the Crazy Fly is, if you ever watch videos of drone swarms from MIT and from USC, they base it off of the Crazy Fly typically. So that's pretty exciting to be a part of that and actually be manufacturing it. It's by a company called bitcraze.io. And then we also do the RF Explorer, which is used by a lot of ham radio enthusiasts as well. This is basically how Seed works. We work with technology providers, such as Intel. We make the technology a little bit more accessible and usable, and we provide it to system integrators or makers, startups. And they target new markets, or they make new apps based on those products. Now, to give an example of this, and you can see like how it kind of goes back and forth. To give an example of this, we helped the BeagleBone org reduce the cost of their BeagleBone. So in this case, the tech provider was beaglebone.org, and we deliver this to system integrators who now use it in 3D printers, automation, smart energy. The BeagleBone is capable of real-time applications, so it's ideal for 3D printing and such applications. And to give you a quick example of technology providers, there's Intel, Renesas, Microsoft, Seeds in the middle. And then we have our system integrators. So system integrators, as I said, they're pretty much anyone. From ArduBoy can be considered a system integrator, Dexter Industries, Make Fashion, Hyper. There's a bunch of different companies that take these and now can actually make product for companies. Many of these companies actually face even more developers and more makers in more DIY type areas. But some of them actually do face end consumers, such as Flashies or Hama. So that's pretty exciting. Or and ArduBoy does as well. So then we also promote. So in this case, like I said, we have 506 distributors, so on and so forth. We promote through maker fairs and Hackster.io, all these other things as well. Now we get to the fun part, the Upboard, Up Squared board specifically. So actually, 2 hours ago, we had a training here where a gentleman from Italy came, and he was actually using the Upboard in his project that he was showing to us. So these photos are actually from today. So the company is called Casa Jasmina in Italian, which I can't do, right? But they're working on smart home solutions. So his name is David Gamba, and you can see their website link down below as well. As you can see, this was today, and the time on that clock is wrong, but I promise it was today. That's just the time in Italy, I guess. And this is a really cool project. As you can see in this one, there's a smart mirror, and that's actually powered by a Raspberry Pi. However, well, I'll get to the upboard in a second here. In this case, this is how we help developers. I'm going to start from left to right here. On the left, they have a speaker that's powered by a Raspberry Pi. It takes voice inputs. Then a microphone that's connected to Raspberry Pi to take your voice inputs and then also play audio through that speaker you see. The smart mirror is actually powered by a Raspberry Pi because he had one lying around. The LED box is actually powered by a simple microcontroller, incredibly simple, small one. The other two boxes, I actually forget their functions entirely, to be honest. But one of them is using our growth sensors and an Arduino board, and the other one is using an ESP32. But what all of these talk to and communicate to is an upboard in the back. Now, this is not the up squared, I don't believe. This is the original. But he is using the upboard, which has the Intel processor, as a server and as a way to filter what actually needs to be sent up to the clouds. This is something I'm really excited about the upboard for. There are plenty of other applications for it, but I can see it with Intel processors being strong, being the server, the actual what goes between smart home and smart buildings and the actual cloud itself. It can filter out the data that you don't need to send that is kind of useless, and then it can also run processes should your connection to the cloud ever stop. And being locked outside of your house because you no longer have internet connection is not exactly fun. Or no longer being able to control your thermostat is no longer fun. So it's important that you do have some edge computing on some server to do this. Here's the Arduino board he was using, the MKR 1000. In fact, David actually used to work for Arduino. And then I'm going to actually get to my demo here. To get to our demo, I am first going to actually power on the board now. So Intel has teamed up with Seed, Arduino, and UP to actually create a very good experience for you. So you can purchase your Upsquared Grove IoT development kit from our website at seedstudio.com. It should be available. It should ship in December on the 8th. There's some resources here you can use, and one of them is if you go to Intel IoT Development, it gives you a guide on how to set everything up, and eventually you will fairly easily set it up to the Arduino Create. I had one issue, but I believe that was due to the firewall here in China. But my understanding is from people that have tested it is that it works really well. My only issue, again, was just due to the firewall. As soon as I was able to get a router that had a VPN, it worked right away, no issue. And now that I have the software downloaded, it's working no issue, even with the firewall. So the board should now be on. I will refresh this page. There we go, now it's on. It will eventually appear online, but refreshing is a quick way to get it to jumpstart and appear. But I did test it earlier, and it took about 2 minutes to recognize that it had been online. And just in case something goes a little weird on messy desktop, just in case it goes weird, I want to SSH into it. So I'm prepared. All right, so we're going to run the blink. And you should hear it beeping in a second. And then we can also use okay. So if I stop it while the sensor is told to be making the noise, it'll keep going indefinitely. And now we'll do the angle sensor, which I can change the frequency. Oh. Let me go ahead and get it to stop making noise for a second. There we go. And that works pretty well. Now, before I show you I'll actually show you the flashing LED real quick before I show you the code and how that works. Hang on as I plug this stuff in. Start blink so I have something going at least at first. Oh. Second, as I was playing with the board, I actually think I did a reset on it. So I'm going to have to reboot the board real quick. But what I'm going to show you now is actually an LED, and so you can see how that works as well. There we go. Excellent. And you can see lovely Jachi behind us. He's really only a hand and a shoulder, but I will get these lovely boards over here. So heads up to my companions here who are about to be on camera. So I'm going to go and show you the board. You can see it here. We have an LED in currently and this rotary sensor. Hey, they waved back at you. And we'll go over to the Arduino again. It is showing it is online. I will start the blinking. And you should be able to see, there it goes, excellent. You can see it blinking. Now, I am aware that this video isn't exactly smooth, but it is blinking with a decent period. So now we'll go to the rotary angle sensor. And again, it's blinked with a decent period. I know it's kind of choppy, but you can see how it's kind of going off and on. When I actually turn the rotary angle sensor, it will increase. And it will get so high that eventually it just stays on all the time, though it will be a little dim. So you can see that it is staying on all the time now. And then, I know you can't see it, but trust me, it does blink at different rates as you rotate the angle sensor. All right. So now we'll go ahead and show you the code area real quick. So to get to the code, you can actually just click on here. You can click on here to see them. I think that works. Ah, here we go. And you can actually see the code running. We can edit it. Unfortunately, I can't edit it right now because I don't have a USB cable with me. Because I am so well prepared, as you can clearly see. But you can easily save it, verify the code. But then to actually, oh, what did I do wrong? High as the voltage level. All I did was change one line. All right. Let's see if it verifies by default. Let me do something real quick before I reconnect. So I'm a little confused because over here, we actually should have two copies, not just this blink, but we should have also had the rotary angle sensor here as well, but that's not here either. So this is actually a little confusing to me because they should already be in the sketchbook from when we uploaded them last time, I believe. I haven't been able to play around with Create that often yet, to be honest. I've been uploading them the old-fashioned way and executing them the old-fashioned way as well, just through the terminal. So I do apologize that I don't quite know why I can't find the two files that were on this board. I know one of our engineers found them earlier, so I do apologize for that, everyone. We'll read. Give me 1 second to see if I can't find the one I want. Well, this will be documented better in the wiki, actually, in the end. So the product's not due to release for a while, so we'll get this all documented so it works fine next time. Yeah, and I'm connected to the right network, too. I connected to the Mimimin or whatever. So unfortunately, we seem to be having a little bit of issues here. And I'm about at my 40 minutes to talk about all this fun stuff. With that, I guess I'm done showing the demo. I do apologize that it wasn't working that smoothly. I haven't really used the Arduino Create that much. So it was a little bit of a challenge for me to learn it in the 2 days before this, to be honest. Previously, I was doing it all through command line. We deal with a lot of different IoT projects. People come to us to ask for help with many IoT projects. So if you want to know more about manufacturing in China, if you want to know more about seed, if you want to know more about the up squared board itself, please ask questions, and I'm more than happy to answer. So also, just so you're aware, our head developer is also with me. So he can answer some questions in chat as well if you have more software-oriented questions and how to work with a company like Seed. So the first question, Can IoT prototyping projects be done for professionally in real-time projects? Um, so I just want to make sure I have the right idea for this. You're asking if boards like the ESP32 can be used in professional products, is what I think you're asking. That is a very common maker prototyping board. Absolutely. It's not that uncommon. It's not something that you would sell to an end consumer. I'll actually give a link in chat. I don't really want to sell us or anything, but we do have a module that you can put onto boards that a lot of people do. So I'll send you two examples. One's an ESP, and one is actually our product. The one I'm sending you is actually discontinued. But people actually do put these on products they will use in real environments for companies. They typically, and this is because it's cheaper to put on modules to a product than it is to actually make your own module. So if you can buy like a module like this that I linked in the chat for say $4 a module, it's a good way to do it, because if you try to put modules on your own board in some cases, you might have to go through some more FCC certification, which would cost a couple $1,000s or up to $20,000 depending what you do. So it can be much more cost effective if you're only making about 2,000 or 3,000 boards at most or less, to use modules such as the one I linked. And there's more modules like that. We have one that we call the YO Core. And there's plenty of other ESP modules out there, Arduino modules. And many of them are actually pre-certified for FCC, as I was kind of saying. So you don't need to get recertified for those. So it can really lower your costs. Does that answer your question? Okay, excellent. Now the ESP32, I don't think, or the ESP8266, I don't actually think it's the best for real time, but you can actually buy modules that are capable of doing real time just fine and pop them on as well. Yes, I know it is discontinued, and I'm kind of happy I did that. I don't know how Intel feels about me like really pushing all of our products on here easily. You can visit our site for different modules. If you type in module, I'm sure something should pop up. Yeah, some things pop up, like we have particle modules that we sell. So I guess I'll link one of those real quickly. This is for their, what they call the P0, the Photon Zero, I believe. And this is a module that you can use. This one is in stock. Now, this one, I think you are locked into their cloud for the most part. But it's just one example of modules that people do use in real products. Now, for the other question that was asked, I apologize for the delay there, TJ. How do you base your pricing for POC projects? I'm going to ask a really lame question. What do you mean POC projects? Again, if you want to learn more about manufacturing and how that works, I'm plenty happy to answer these questions. China is where you want to go to do manufacturing, and C is one of the most well-known. Ah, okay, got you. So proof of concept. Okay. So we typically don't do a lot of those. The reason why is it's expensive. To have us work on a project that isn't necessarily going to go to manufacture costs quite a bit of money. If you do know, if we are fairly certain you're going to go to manufacture, we feel better about it. And truth be told, Seed can only take on maybe about 6 projects at a time to actually go through, manufacture, and produce. We can always go back and manufacture them later as well, easily. But it's the engineering. We can only take about 6 projects at a time. And usually about 2 to 3 of those are internal projects, and we take on 2 to 3 OEM, customization, or ODM projects. So we try to look for ones that likely are going to go further. So to answer you a little bit more, one of the best ways to do, I would say, is to find some college students who might be willing to work on something like that. A lot of times it can be used for their capstone graduation projects. And then you can get it manufactured through something like Seed Fusion. And there are other services similar to that as well. It's kind of hard to find an engineering company that's willing to do that, especially if you don't have a lot of capital to put into it, because many of them don't want to risk taking They don't want to take shares, or they don't want to take part of the company. They don't want to invest in the company exactly. That has very low return for companies that do engineering typically. So, sorry. But you can always pitch it and see what happens, of course. Again, we're Seed. We're very excited to be here and speak to you all. Best IoT developer site. So that's a very hard question. And the reason for that is, and I'm sure other speakers have said this, what is IoT? There's so many technologies that people define in IoT. So the best IoT sites are going to oftentimes be technical sites related to whatever area you're interested in. If you're interested in smart homes, smart buildings, there are actually some great sites out there dedicated to that in forums. There are some Slack channels, etc. Personally, there are a few subreddits I think are great. We tend to deal with more with embedded IoT, and so there's a lot of great help you can find on Reddit r/embedded. They actually usually are very helpful, I find. And then they also have like IoT chat, developer chat. The truth is, most developers these days have a little bit of experience working on some form of IoT project, whether it be the server side of IoT or the embedded side. It's hard to really track them down and find them exactly. So there are some sites out there. But my best luck, and a lot of my developers' best luck, has actually been when they've gone to general developer websites and they've asked a pool of people that have a lot of different experiences. The IoT sites themselves, there's some good communities out there, but we find it better to reach a much broader audience of developers in total. So as much of a non-answer as that was, I hope it was helpful. Okay, in your case, you're not going to find an all-in-one answer, because the reality is each of those needs a different type of IoT technology. So for smart farming, a lot of farms don't get really good LTE coverage. So you'd want to do something like LoRa, Sigfox, and that'd be an entirely different area to look into. And then for digital marketing, you're probably going to have Wi-Fi almost at all times. What we really need in the IoT industry is more standards on how things communicate with each other. You have things like Nest, your Chrome stick, your Intel sticks for the TVs, your Apple TV. But if they can all communicate and have a similar protocol to actually talk to each other, that's very helpful. And I think Mozilla is trying to make a standard for at least smart home devices to speak with each other. And smart home devices might actually leak into smart retail, smart building as well. But the Mozilla Foundation is doing that. They're trying to find a standard. And I think you can find that if you go to, I think this is the right one. Mozilla 1 or 2, mozilla.org. So the Mozilla Foundation is trying to find some standards for that. And you can find more information on that at iot.mozilla.org. That might be a good place to start and talk to them, because they reach out to a lot of people in every area you mentioned, talking to them about IoT. So the Mozilla Foundation could point you in good directions, I think, since so many people do talk with them. So I would really recommend talking to the Mozilla, which, as you might know, they also run Firefox browser. And one thing, as you do this research, remember, like, the primary thing is model. What is the ROI for the smart building, the smart farming? What is the ROI, and what technologies are going to best help them? Because in the end, this will be a business decision. So email me at seth.welday@c.cc. Or actually, one of my colleagues will get back to you quickly on that. I think he's giving his email now. Yeah, email Jachi-san, and he will actually find out that answer for you quickly. We'll have it for you as soon as our colleagues get into work tomorrow. All of them are actually, they've gone home by now. So we'll give you that information bright and early in the morning for us. All right, take care, everyone. Have a good night.